Hi, welcome back to my channel. My name is Gina. In this video, let's talk about the rule of thumb of whether we can find one single solution, no solutions, or infinitely many solutions from a system of equations. A system of equations is two or more equations involving one or more variables. For example, let's start with a simple one. 2x plus y equals to 1. And 3x minus y equals to 5. Here is a system of equations. This system of equations, there are two unknowns. The unknowns are the x and the y. And we have two equations. Let's call the first one equation 1 and the second one equation 2. Normally, how do you find the solution to this kind of system of equation? We usually use some algebra. For example, here I can use equation 1 plus equation 2. So the plus y and the minus y can cancel out. Then I get 5x equals to 6. So I get x is 6 over 5. Then I substitute x into one of the equations, for example, equation 1. Then I can find y. So 2 times x is 6 over 5, plus y equals to 1. So I get y is 1 minus 12 over 5, which equals to negative 7 over 5. So here my solution, I only have one solution, is when x equals to 6 over 5 and when y equals to negative 7 over 5. How about a system of equation with three variables? Here we have three equations. Let's call them equation 1, 2, and 3. This system of equations, we have three unknowns. They are x, y, and z. And we have three equations. How many solutions we can get? Let's try to do the same trick. Let's do equation 1 plus equation 2. Then we get 5x equals to 15. So x equals to 3. Then we can substitute x equals to 3 back to our system of equations. And then we can find the y and the z. So for this system of equation, we'll also get one solution. So the rule of thumb is how many unknowns we have, then how many equations we need to find one solution. In other words, when the number of unknowns equals to number of equations, then we'll get one single solution. How about number of unknowns is smaller than number of equations? Let's start with a simple one. 2x equals to 6 and x equals to 2. Here we have one unknown, which is the x. And we have two equations. Let's call them equation 1 and equation 2. From equation 1, we get x equals to 6 divided by 2, which is 3. But this does not equal to equation 2. Equation 2 is x equals to 2. So the rule of thumb for when number of unknown is smaller than number of equations is we have no solution. It is possible that the second equation also satisfies equation 1. For example, if we have 2x equals to 6 as the first equation, a second equation we have x equals to 3. Then in that case, we'll get one solution. But for most of the time, if number of unknowns is smaller than number of equations, we have no solution. How about when number of unknowns is greater than number of equations? Here we have three unknowns, x, y, and z. But we only have two equations. Let's call them equation 1 and equation 2. How many solutions will we get? We can get infinitely many solutions. For example, let's set z equals to 0. Then we substitute z equals to 0 into our equation 1 and 2. Then we get two equations with two unknowns. 2x plus y equals to 1. And x minus 2y equals to 3. We can also have when z equals to 1. We substitute z equals to 1 back to our equation 1 and 2. We get again two equations with two unknowns. 2x plus y and plus z equals to 1. Let's just move the z to the right hand side. 1 minus 1 is 0. Equation 2 we have x minus 2y equals to 3 minus 2z. And z is 1, so 3 minus 2, right hand side is 1. Similarly, we can have z equals to 2. We'll get another two equations with two unknowns, and so on. We can have z equals to 3, 4, 5, or even 0.1, 0.2. So here we will get infinitely many solutions. Now let's see the problems geometrically. An equation with one unknown. Let's say ax equals to b. This is a point in space. We can solve for x. X is b divided by a, which is a point in the space. And if we have ax plus by equals to c, we have two variables, x and y. This will form a line. We can solve for y and write this equation as negative a divided by b times x plus c divided by b. You are probably more familiar with this form, but on the left, if we have some constant times x plus a constant times y equals to another constant, this is also equation for a line. How about when we have three variables? Ax plus by plus cz, and this equals to another constant, b. What would this be? This would be a plane. So now we can think the system of equations geometrically. When we have two equations with two unknowns, then we can think it as two lines lying on the same plane, and we want to find their intersection. So, if we have two lines, we'll only get one solution, one intersection. However, it's also possible to have zero solution. That is when if the lines are parallel. These two lines are lying on the same plane, but they have no solution. They will never intersect. Similarly with three dimensions, if we have two planes, the intersection point, instead of point, we have an intersection line. So when we have three variables and two equations, we get infinitely many solutions because the solution will be a line. However, if we have three planes, then the solution will only be one dot, and we get one single solution. So here's the rule of thumb. When the number of unknowns equals to number of equations, then we get one single solution. But if number of unknowns is smaller than number of equations, then most of the time we'll get zero solution. And if number of unknowns is greater than number of equations, then we get infinitely many solutions. And that is the end of the video. This is a brief introduction to linear algebra. If you want to learn more about linear algebra, please comment below. If you like my videos, please like and subscribe, and I'll see you in the next video.